Perimeter is the measurement around a boundary. A formula can be applied to solve the perimeter of a rectangular figure. Students should be able to apply the perimeter formula for rectangles in real-world and mathematical problems. Let's look at some examples of perimeter. If we're looking at this figure and we want to know the perimeter of the figure, we must add up all of the sides together. Looking at the pattern when adding up all of the sides, I see that I am adding together the length twice and the width twice. I can use that information to create a formula where perimeter equals the length multiplied by 2 added together with the width multiplied by 2. When I plug that information into the equation, I see that 2 times 5 is 10 and 2 times 3 is 6. I then add together 10 plus 6 to calculate the perimeter of the figure, which is 16 units. With rectangles, we know that the opposite sides are always equal to each other. Since we know this, we do not always have to be given each side of the rectangle. We can be given the length and the width and plug in the information into the perimeter formula. I can see with this figure that I can multiply 2 times 9, which is the length, and add it together with 2 times 6, which is the width. 18 plus 12, so the perimeter of this figure is 30 units. We know that a square has all equal sides and all equal angles. With a square, we only need to be given one side in order to solve the perimeter of the figure. We can plug the number into the formula to solve the perimeter of a square. The perimeter of this figure is 24 units. Sometimes we are given the perimeter of a figure and we must find the measurement of the sides. First, we can plug our known information into a formula. We know that the perimeter for this figure is 30. We know that the length is 6 units, and so we can plug that into the formula of 2 times 6 plus 2 times width equals 30. 2 times 6 equals 12, and again, the perimeter is 30. We can now subtract 12 from 30 to find the remaining length of the 2 missing sides. So now we have 18 equals 2 times W. So we need to think of something that can be multiplied by 2 to get to 18. Since we have to multiply the width by 2 to find the length of the missing side, let's divide the remaining length by 2 to find the length of each side. 18 divided by 2 equals 9. And now we can plug 9 back into the formula for width and 6 for length to check our answer. 2 times 6 equals 12, 2 times 9 equals 18, and 18 plus 12 equals 30. Area is the measurement of square units within a figure. A formula can be applied to solve the area of a rectangular figure. Students should be able to apply the area formula for rectangles in real-world and mathematical problems. Let's look at some examples of area. The area of a figure is the number of squares it requires to cover it completely, like tiles on a floor. If we look at the figure pictured, we have a model of what an area rug could look like. Instead of counting all of the squares in the area, we can simply count the squares along the side, which represent the length, and across the top, which represent the width. In this figure, we can see that the length of the side is 5 square units, and the length of the top is 6 square units. We can use the formula for area, which is length times width, to see that it takes 30 squares to cover this area, or 30 squared units. Once we are able to understand that area is measured by the number of squares it takes to cover an area, we can move on to models that do not involve visualizing the individual squares, but just visualizing the entire area. In this model, we have a rectangle with a length of 9 square units and a width of 7 square units. Since we know the formula for area is length times width, we know that it would take 63 squares to cover this area, or 63 square units. We are told that this figure is a square. We know that a square has all equal sides. Since we are given that one side is 4 square units, we also know that the other sides are also 4 square units. We can apply the formula for area to find the area of this square. The area for this figure is 16 square units. Sometimes we may be given the area of a figure and the side of a figure, and we must determine the measurement of the unknown side. Take the example given. The area of the figure is given as well as the width of the figure. In this case, we can use the area formula and divide to reach the measurement of the unknown side. We can either think something times 7 equals 35, or 35 divided by 7, and we know that that equals 5. So the measurement of the unknown side is 5 units. To review, perimeter is the measurement of a boundary, and the area is the number of squares it would take to fill a specific area. Looking at the figure above, the length of the side is 7 units, and the width of the other side is 11 units. Using the formula for perimeter and adding up all of the sides, the perimeter for the rectangle is 36 units. When using the area formula, the area of the figure is 77 square units. Rectilinear figures are defined as shapes where all of the edges meet at right angles. Typically, rectilinear figures are rectangles and squares that are put together to make a larger shape. To find the area of rectilinear figures, they can be decomposed into smaller rectangles and squares to solve the area of the specific figure. Within a rectilinear figure, there are smaller rectangles. In order to figure out the area of the entire figure, you must figure out the area of the smaller rectangles. I will split the figures into 2 separate rectangles. I will then figure out the area of the first rectangle. I see that the width is 4 units and the length is 7 units. Using the area formula, I will multiply 7 times 4, and that gets me to 28 square units within this rectangle. Next, I will find the area of the second rectangle. I see that the width is 4 units, and the length is also 4 units. Using the area formula, I will multiply 4 times 4, and that gets me to 16 square units. Once I find the area of both of the figures, I add together the area from the 2 figures to find the area of the entire figure. 28 square units plus 16 square units equals 44 square units. So this rectilinear figure measures 44 square units of area. Sometimes with rectilinear figures, not all of the measurements are given, and we must find the measure of the unknown sides. We must first split the rectangle into 2 parts to find the area of the 2 figures. There are 2 sides that are unknown, and we must use the information given to find the length of the 2 sides. Let's look at the red dashed line. We know that if we extend that side, it would be 11 units because the opposite side is 11 units. We also know that part of that side is 6 units. 11 minus 6 equals 5, so the measure of the missing side is 5 units. Now let's look at the dashed blue line. We know that the opposite side is 12 units, and that part of the length of the blue side is 5 units, so 12 minus 5 equals 7. So the missing side is 7 units. Now that we know the length and width of the unknown sides, we can use the area formula to solve the area of the 2 figures. 11 times 5 equals 55, so the area of the first rectangle is 55 square units. 7 times 5 is 35, so the area of the second rectangle is 35 square units. 55 plus 35 equals 90, so the area of the entire figure is 90 square units.